Hello, I'm Phoenix City Council Member Carlos Garcia with District 8. We will never replace in-person teaching, but during these trying times, our children still need to continue to learn. The City of Phoenix is proud to partner with both the Osborne and Roosevelt school districts to bring you PHXTV Classroom Study Hall. Youth and education is a priority for Phoenix. That's why the city is bringing you the study hall to your home during this next hour right here on Phoenix TV. Learning should never stop, so get ready for class. Here's the study hall.
Good morning, students. This is Michael Roberts, Superintendent of the Osborne School District.
Good morning, and I'm Quentin Boyce, Superintendent of the Roosevelt School District. We are excited to be here today to read a book, a very special book to our entire community. That book is entitled Bringing the Rain to Kapiti Plain by Verna Ardema. This book is really special because it comes from a tribe, the Nandi tribe in Kenya. And Kenya is in Africa. Boys and girls, can you identify where Africa is on our global map? Good. Now that you've found Africa, can you identify where Kenya is? A little hint, it's on the eastern part of Africa. Now think about it, east. Where is that? North? South? West? East. Kenya is in the eastern part of Africa. Did you find it? Good job.
This is a special book in the way that it's written, too. This story is what you call a cumulative story. That means it's going to start with something, and it's going to repeat it over and over and over. I'll give you an example. There's an old English nursery tale that's called The House That Jack Built. Have you ever heard of that? I remember hearing it when I was a kid, and I loved it because of the way the story moved and the way things repeated over and over. So it went like this. It started off really simply. This is the house that Jack built. Then the next line said, this is the malt that lay in the house that Jack built. And then the next page said, this is the rat that ate the malt that lay in the house that Jack built. Then comes a cat. What do you think the cat's going to do to the rat?
Oh, I can only imagine.
The next page says, this is the cat that killed the rat that ate the malt that lived in the house that Jack built. So every time it goes to a new page, you get a new character or something new that happens, and then it repeats everything that came before it. We're going to have that happen in this story. You ready to find out how it goes? We'll get through a couple pages first, and then the repeating part is going to start happening. I'll let you know when that part's coming up. But there's something else that you can find in these repeating cumulative stories. It's got a rhythm to it. Can you clap like that with me? Let's try it. Now here's how the house that Jack built goes. This is the house that Jack built. Okay, next part. This is the malt that lay in the house that Jack built. We're going to have that happen in this story, Bringing the Rain to Kapiti Plain. Are you guys ready?
Yeah.
All right. Get us started, Quentin.
Let's do it. This is the great Kapiti Plain, all fresh and green from the African rains. A sea of grass for the ground birds to nest in, and patches of shade for wild creatures to rest in. with acacia trees for giraffes to browse on, and grass for the herdsmen to pasture their cows on.
I think I kind of got that rhythm.
I can kind of hear it.
Can you read that again? And I'm going to see if I can quietly clap the rhythm with you.
Let's do it. This is the great Kapiti Plain, all fresh and green from the African rains. A sea of grass for the ground birds to nest in, and patches of shade for wild creatures to rest in, with acacia trees for giraffes to browse on, and grass for the herdsmen to pasture their cows on.
I got it.
I think I got it too. I think I got it too.
But one year the rains were so very belated that all of the big wild creatures migrated. Then Kipat helped to end that terrible drought. And this story tells how it all came about. This is where it's going to start repeating.
This is the cloud, all heavy with rain, that shadowed the ground on Kapiti Plain.
This is the grass, all brown and dead, that needed the rain from the cloud overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain. Did you notice the part that repeated? I read this first part. That was brand new. And then I repeated everything that Quentin read. I'm going to read that one more time. I'll read the new part, and let's see if you can join in with doing the second part with me. This is the grass, all brown and dead, that needed the rain from the clouds overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain. We're going to keep reading it, and you guys are going to get the rhythm of this. I know it.
These are the cows, all hungry and dry, who moved for the rain to fall from the sky, to green up the grass, all brown and dead, that needed the rain from the cloud overhead, the big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain. I hear it still. It continues to repeat.
Now we're going to meet one of the characters in the story. You heard his name earlier, Kipat. This is Kipat, who watched his herd as he stood on one leg like the big stork bird. Look at Kipat, how he's standing. Do you think you can do that? Stand up. Come on, stand up at home. Try it. You have to have a nice straight back. Stand up nice and tall and see without falling if you can pull one leg up and stand like Kipat, who stood on one leg like the big stork bird. I think I'm going to try it. Let's see if I can do it. Okay. Oh, he's here on the cover too. He was doing it right from the very beginning. Okay, so what did I say? I have to get a good straight back, get my balance, and I'm going to stand on one leg like the great stork bird. I did it. Can you do it, Quentin?
I think so.
Let's try it.
I think so. Let's see.
Straight back.
Straight back. Okay. One leg up.
One leg up.
One leg up.
Ooh, I lost my balance. I'm going to try it again.
One leg up.
I did it.
Am I doing it?
Are you doing it at home? All right. Let's get back to our story and see what Kipat does. This is Kipat, who watched his herd as he stood on one leg like the big stork bird. Kipat, whose cows were so hungry and dry, they mooed for the rain to fall from the sky, to green up the grass all brown and dead that needed the rain from the cloud overhead, the big black cloud all heavy with rain that shadowed the ground on Kapiti Plain.
Looks like we're introducing a new character. This is the eagle who dropped a feather. You can see him right here, very big. This is the eagle who dropped a feather that helped to change the weather. It fell near Keepot, who watched his herd as he stood on one leg like a big stork bird. Keepot, whose cows were so hungry and dry, they mooed for the rain to fall from the sky. To green up the grass, all brown and dead, they needed the rain from the cloud overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain.
This is the arrow Keepot put together with a slender stick and an eagle feather. From the eagle who happened to drop a feather that helped to change the weather. It fell near Keepot, who watched his herd as he stood on one leg like the big stork bird. Keepot, whose cows were so hungry and dry, they mooed for the rain to fall from the sky, to green up the grass all brown and dead that needed the rain from the cloud overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain. I noticed Quentin was really keeping the rhythm as I read the story. I saw his hand tapping. I bet some of you had your hands doing the same thing. Could you feel the rhythm?
I could.
I'm going to read the second part from about the cows who were so hungry and dry, and I'm going to watch you guys to see if your hands are patting along with me. And I'm going to pat too. Keepot, whose cows were so hungry and dry, they mooed for the rain to fall from the sky, to green up the grass all brown and dead that needed the rain from the cloud overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain. I saw you do it.
This is the bow, so long and strong strung with a string, a leather thong. Bow. Do you know what a bow is? Do you know what a bow is used for? How do you use a bow? We know arrows go with bows, and that motion goes something like this. You pull it back on the string that he talked about.
There it is. There's the string. So watch Quentin when he does this. Here's the bow. Pull the string back.
And you let it go. So there's an arrow. And I wonder how the arrow is going to fit into the story, the bow and the arrow. Because remember, the title is Bringing the Rain. So we're trying to bring rain. This is the bow, so long and strong strung with a string, a leather thong. A bow for the arrow, Keepot put together with a slender stick and an eagle feather. We met the eagle. From the eagle who happened to drop a feather that helped to change the weather. It fell near Keepot, who watched his herd as he stood on one leg like a big stork bird. Keepot, whose cows were so hungry and dry, they mooed for the rain to fall from the sky. To green up the grass, all brown and dead, they needed the rain from the cloud overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain.
Quentin just talked about it. We're trying to bring the rain. Keepot got the feather. He used it to make that arrow, right? And that went in the bow?
Yes.
Here goes the big part of the story. This was the shot that pierced the cloud and loosed the rain with thunder loud. A shot from the bow so long and strung with a string, a leather thong. A bow for the arrow Keepot put together with a slender stick and an eagle feather. From the eagle who happened to drop a feather that helped to change the weather.
It fell near Keepot, who watched his herd as he stood on one leg like a big stork bird. Keepot, whose cows were so hungry and dry, they moved for the rain to fall from the sky, to green up the grass all brown and dead. They needed the rain from the cloud overhead, the big black cloud all heavy with rain that shadowed the ground on Kapiti Plain.
All of our characters have come into the story. It's all been put together, but that was so long and repeated everything. It took 2 whole pages. Quentin, let's do that again.
Let's do it again.
I'll read the first page where he pierces the cloud, and then you keep it going. And all of you at home, see if you can keep the rhythm and also see if you can remember the story and join in on some of the words. All right, let's just keep this going right through 2 pages. I'll do the first page. Here we go.
I'm ready.
This was the shot that pierced the cloud and loosed the rain with thunder loud. A shot from the bow so long and strung with a string, a leather thong. A bow for the arrow Keepot put together with a slender stick and an eagle feather. From the eagle who happened to drop a feather that helped to change the weather.
It fell near Keepot, who watched his herd as he stood on one leg like a big stork bird. Keepot, whose cows were hungry and dry, they moved for the rain to fall from the sky. To green up the grass all brown and dead, they needed the rain from the cloud overhead. The big black cloud, all heavy with rain, that shadowed the ground on Kapiti Plain. Starting to rain, too. Notice it's raining.
Do you see a difference between what the ground looks like here?
Yes.
All brown and dead. And do you see what happened here? What happened? So the grass grew green and the cattle fat, and Keepot got a wife and a little Keepot.
Who tends to the cows now and shoots down the rain when black clouds shadow Kapiti Plain.
Did you enjoy that story?
I did.
It's one of my favorites. I remember when this book was read on a show called Reading Rainbow, all the way back from when I was 10 years old. And now I get to read this story and share it with you. So happy that we got to share this. And now we need to talk about what you can do now that you've heard the story. There are 2 things that we talked about in this story. Well, one that we already talked about, and something new that I'm going to ask you to do. So Quentin, what was it that we were doing throughout the story?
We were keeping the rhythm and understanding the tempo. So keeping the rhythm, understanding the tempo.
So let's see if you can look this story up online and you can have all the words to the story. See if, first of all, you can read it and keep the tempo like the story has. Then see if someone in your house can read it and you can clap and help them keep the rhythm. Then see if they can clap or they can read and then you clap to help them keep the rhythm. There's one other challenge in here. I'm going to just look at one page and give you an example and see if you can do this at home. There is a lot of rhyme in this story. But one year the rains were so very belated that all of the big wild creatures migrated. Then Keepot helped end that terrible drought. And this story tells how it all came about. Do you hear the ends of some words? Belated, migrated. Drought, about. Rhyme really helps this story move along too. So we have tempo or rhythm, and we have rhyme. So when you get a chance to either look for this book in the library or you can check it out online, just type in Bringing the Rain to Kapiti Plain. See if you can find the words and see if you can keep rhythm and find the rhymes that are in the book.
Thank you, guys. It's been such a pleasure. We were happy to be with you, and please know that we love and we miss you.
See you soon.
Take care.
Hi, boys and girls. It's Miss Sanabali. I teach kindergarten at Encanto Elementary School. I'm so excited to get to do another math lesson with you today. But before we get started, let's say our chant. Are you ready? Who's a mathematician? I'm a mathematician. That's right, mathematicians. So, I left a clue on what we're going to be working on today. Can anybody guess what we're going to work on today? That's right, shapes. We're going to work with shapes. Now, there's a couple of reasons why I love working with shapes. One, shapes are everywhere. Look around the room that you're in right now. What shapes do you see? Tell me the shapes that you see. Excellent. I heard rectangle, circle, square, triangle. When I look around this room that I'm in, I see all of those shapes too. Shapes are everywhere in our environment. Another thing that I love about shapes is I can take one shape and another shape, put them together, and I've made a new shape. Fun fact about shapes. Did you know that most bridges are made with triangles? Because triangles are so strong. Shapes are amazing. So we're going to work with shapes today. We're going to talk about some of the attributes of shapes, and then we're going to draw a picture using shapes. So let's go ahead and get started. Now, attributes are ways to describe what a shape is. So I'm going to use attributes to describe a shape. One attribute that a shape can have is a line or a side. Another attribute that a shape can have is this. That point is called a vertice. Now, some people call it a point, but we're about to be first graders, so let's use that word vertice, okay? One thing that helps me remember what a vertice is I do this with my hands and I make a vertice, and then repeat after me. A corner, corner, corner is the vertice. Let's say that one more time. Corner, corner, corner is the vertice. That's right, and make sure you make that vertice with your hands to remind you that that point, that corner, is that vertice. So a shape can have a line or a side, a vertice, but there's some shapes that don't have a line, don't have a vertice. They're going to have this, which is a curved edge. So here are some of the attributes that you will see in a shape. I'm going to hold up some cards that have a picture of a shape. When I do this, I want you to shout and tell me what shape that you see. Are you ready? All right. What shape do you see? Square. Triangle. Circle. Rhombus. Rectangle. Excellent. All right, mathematicians, I'm going to tell you some shape riddles. When I'm done with the riddle, I'm going to ask you to tell me what shape did I just describe. Are you ready? Great. Here's our first riddle. I have 4 sides. I have 4 vertices. My sides are all the same. I have straight lines. I look like a box. What shape am I? a square. Great job, boys and girls. Are you ready for the next riddle? I have 3 sides. I have 3 vertices. My lines are straight. I look like a party hat. What shape am I? Triangle. Excellent job, mathematicians. Okay, our next riddle. Ready? I have 0 sides. I have 0 vertices. I have a curved edge. I look like a ball. What shape am I? What shape did I just describe? Circle. You guys are so good at doing this. Next riddle. I have 4 sides. I have 4 vertices. My lines are diagonal. I look like a kite. What shape am I? A rhombus. Excellent. Man, I am not fooling you guys with these riddles. Okay, one more riddle. Are you ready? Great. I have 4 sides. I have 4 vertices. 2 of my sides are long. 2 of my sides are short. I look like a door. What shape am I? A rectangle. Great job, mathematicians. You really know your shapes. Now let's put that knowledge of our shapes to draw a picture. So I'm going to need you guys to get a piece of paper and a pencil. So you're going to get a piece of paper and a pencil. Go ahead and grab your materials right now. While we're waiting for you guys to grab materials, do you want to hear a joke? All right, so what is a butterfly's favorite subject in school? Mathematics. All right, friends, I hope that you were able to grab a piece of paper and a pencil. Okay, so I'm all ready with my piece of paper and my pencil, and I kind of hung it up like this so you can see it. Now, I want your paper to be sideways, like this ways, not like this, like the long ways. Okay, so we have it. Now, we're going to use our shapes to draw a picture. I'm going to tell you what shapes to draw, and I'm going to draw it here, and then I want you to also do it at home. I have a colored pencil that I'm going to use so that you can kind of see my lines a little bit better, but I really recommend that you use a pencil at home, because if you make any little mistakes, you can kind of cover it up. But don't worry, because you're not going to make mistakes, because any art is beautiful art. Are you ready? So the first thing that we're going to draw is a triangle. Now, a triangle has 3 sides and 3 vertices, but we're just going to draw 2 sides right now, and then we're going to add the 3rd side in just a second. So it's going to be a triangle, but just not quite a triangle yet. So I'm going to look at my paper, and I'm going to kind of pick a little bit high up on my paper, and I'm just going to draw just like a little circle so that I have it in my brain where I'm going to go from my triangle, and I'm going to go down with my straight line. And then I'm going to go down again. It was kind of hard to see. So I have my triangle kind of like this. Do you see that? So I drew part of my triangle, but I didn't draw the line here. Now, from that same spot, I'm going going to draw another line, but I'm not going to do like a curved edge, but I'm going to make it like a little bit kind of curvy, not too bad. And I'm going to go all the way down. So it kind of looks like this. I guess we could describe it as looking like a Christmas tree, maybe like a banana. We look at it like that. Now that I have these 3 lines drawn like that, now I'm going to draw the line at the bottom. So I'm going to draw my line at the bottom right here. If I need to connect it to the bottom, I'll just do that. Let me see. I'm going to move to a marker so you can see it a little better. It's kind of hard to see what we're doing. All right, that's much better to see. Aye, Mrs. Annabali. All right, does everybody have this so far? Great. Now, I'm going to draw another triangle right here. Not as big as this triangle, but just a little triangle right here. So I'm going to draw a little triangle right here. All right, does anybody know what we're drawing yet? No? Oh, I know. Okay, so I got my other triangle right there. Now, I'm going to draw part of a circle or part of an oval right here. Just like that. And then I'm going to draw a circle right here. Go ahead and draw that oval and the circle on your paper. Does anybody know what we're drawing yet? Okay, those are some good ideas. Let's draw more to see. Inside this circle, I'm going to draw another little circle just like this, just like right here. Just like that. So it kind of makes like an eyeball. So I have that. All right. Now, in this circle right here, I'm going to draw some triangle teeth. Now, I'm just going to go like this with my triangles, up, down, up, down, up, down. And I'm going to also do it at the top. Up, down, up, down, up, down. Wow, you guys are really good at drawing triangles. Does anybody know what we're making yet? Some of you, I think, know what we're going to do. All right. Now, mathematicians, I'm going to draw 3 kind of curvy lines right here. Just go whoop, whoop, whoop. What did we just draw? We just drew a shark. Look at how we took triangles and circles and we made a shark. Good job, mathematicians. But what does a shark like to eat? Fish. Let's add some fish to our paper. So I'm going to draw another triangle. Just going to draw another triangle just like this. And then I'm going to add a circle, or actually an oval right there. So I have my fish. And then I'm going to add a circle for an eye. Excellent drawing, boys and girls. I'm going to add a few more details to my picture. You can also add these details. You can also add different details. So I'm just going to kind of put some little like circles here as kind of like bubbles. And because sharks live in the ocean, I'm going to add kind of waves. And then I just kind of do half circles. I go like a half circle, doing that curved edge. And you know what? I'm going to add another fish down here. So I'm going to do a triangle and then an oval and a circle for the eye. Now, no picture is complete unless we color it. Sharks aren't just like blue outline. Fish aren't just blue outline or pencil outline. We gotta color them in. So I kind of colored one of these pictures in earlier. And you can do the same. So I colored my shark in gray and added some blue and did an orange fish, and I added a red tongue to my shark. But this is also your picture, so add whatever colors you want and do whatever pictures that you want. But isn't this such a fun way to use shapes and make a picture? Thanks for drawing with me today. Okay, mathematicians, let's go ahead and review the attributes of a shape. They can have lines or sides. A shape can have a vertice. The corner is the vertice. Or a shape can have a curved edge. Now we used all of these attributes and shapes to help us draw this picture. So like I said, we can take shapes, add different shapes, and look at what we made. We made new shapes. We drew a picture using shapes. That's what I love about shapes. Thank you so much for working with me today. Once again, I have so enjoyed our time together. Before we go, let's say our chant. Are you ready? Who's a mathematician? I'm a mathematician. All right, mathematicians, until next time, have a wonderful week. Also, look out for some of those shapes. What do you see around your neighborhood, in your car, in your house? Ask your mom and dad if they know their shapes. Bye, guys.
Good morning, everyone. My name is Miss Damian, and today we're going to learn about shapes. So what is one shape you know? Those are some great shapes. Yep, I heard squares, triangles, rectangles, circles. Today we're going to learn a little bit more about shapes, not just what the names are and what they look like, but if we look at our objective, it says, we will be able to identify and draw shapes based on their attributes. Okay, so that means that we're going to be able to make and find shapes based on their attributes. That big word attributes, we haven't learned it yet, but today we're going to talk about that. Before we begin, we're going to go ahead and do some fact fluency. Fact fluency is important to help us learn how to do math quickly. This is going to help us when we're doing even larger problems with bigger numbers. So let's go ahead and begin. Fact fluency. Remember, you look at the problem and you solve it quickly. 4 plus 5 is 9. 13 plus 2, 15. Good job. 12 minus 3, careful with the symbol. Minus means you take away. Minus means you take away. 12 minus 3, 9. 10 minus 7, 3. 20 minus 5, 15. 16 plus 1, 17. 8 plus 5, 13. Good job. 17 minus 8. Oh, this one's challenging. 9. Good job. 19 minus 11, 8. 13 plus 4, 17. Oh, that was the end of the fact fluency. Now we're going to go ahead and begin talking about our lesson. Now, there are some key words you need to know before we begin, so let's go ahead and talk about it. The word was attributes. We saw that in our objective, but most of us don't really know what attributes are. So let me tell you, you have to use your eyes when you talk about attributes. Attributes, say it with me, attributes. Say it one more time. Attributes, it describes how something looks like. So I'm pointing to my eye because it's going to help me remember that attributes describes how something looks like. Okay? For example, we have this apple. If I were to describe its attributes, I can say the apple is red, correct? We can also say that the apple is round. I see some roundness going on. I can say the apple is spotted. If you look closely, I can see some little teeny tiny spots. Now, if we were to look at this cactus over here on this side, what attributes does the cactus have? Something it looks like. So if I were to describe its attributes, how it looks like, I can say, think for a minute, a few seconds actually, and tell me, what's one attribute you see? Ooh, I heard some good ones. I heard pointy, I heard tall, I heard green. Those are all great attributes. And attributes describes how something looks like. Okay, don't forget that an attribute describes how something looks like. Let's go ahead and keep going. Another thing we're going to talk about is closed versus open shapes. Closed shape, open shape. Say it with me. Closed shape, open shape. We're going to talk a lot about closed shapes. If we were to look at both closed and open shape, what do you see that's the same about both of them? Yeah, I see that as well. I see that they have lines. So both closed shape and open shape have lines. Here are my closed shape. Here are my open shape. They both have lines. I see that they have corners as well. But the only difference, now let's think, how are they different? They are different because go ahead and share it out loud. How are they different? Ooh, I heard some great ideas. I heard they're different because this one doesn't have a closing area and this one doesn't close either. Yeah, so that's why these are called the open shapes. Closed shape, open shape. Today we're talking about closed shape. Oops. Today we're going to talk about shapes. So we're going to give you some examples and some keywords you need to know about closed shapes. Then we're going to be able to identify, which means find, and we're going to be able to draw or create our own closed shapes and then describe their attributes or based on their attributes. Remember that attributes is how they look like. Okay. We're going to go ahead and start sharing. We're going to work on our paper poster so we can learn some more. Be ready and pay attention. Before we begin talking about what shapes we're going to be making, we're going to talk about attributes that we can see. Remember that attributes is what you see or how they look like. The first one is sides. So the way I remember sides is if I say side. My arm can be a side. So from here to here is a side. From here to here is a side. How many sides do I see? 1, 2. Just say side. Side. A side is a line. Side. Show me side. Side. Correct. Next one we have is corners or angles. Corners or angles. So now if I turn my sides around, I see a corner. Is where two sides connect or meet. Corner. Angle. Corner. Angle. You can say corner Or if you want to be a real math learner, you can say angle, corner, angle, corner, angle, sides, corner, angle. Okay? So it's where two sides meet. So if I have two sides, 1, 2, the corner or the angle is going to be here? No. Here? No. What about here? No. A corner or the angle is where two sides meet. Just like your elbow. Your elbow can be an angle or a corner. Right here. And another one, most times you cannot have a side if it's not straight. Straight. Say it with me. Straight. Make something or show me a line. Make it straight. Show me a line. Make it not straight. All over the place, right? So straight means it's just one line. It doesn't curve, it's straight. It can go any way as long as it's straight, correct. Straight, 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 straight. One more time, let's go over the words. Sides, corners or angles, corners or angles, where two sides meet. Corners or angles, where two sides meet. Corners or angles, where two sides meet. Okay? Where two sides meet. So now you know, if somebody asks you, hey, what's an angle? You can say, where two sides meet. Okay? Now, if I were to ask you, draw a shape or make a shape, remember you still have your paper pencil out, or you can have your sticks or your popsicle or your straws. What if I ask you to make me a shape with three sides? Well, I know that sides look like this or straight. So let's see. If I were to make a shape with three sides, I can do, remember it has to be closed, not open. We're not working on open shapes. We're working on closed shapes. One side, two sides, three sides. That's my shape. Go ahead and try making a different shape with three sides. Can I challenge your brain? I see some of you guys trying to do this. The sides are longer on top and on the short side. Correct? As long as it has three sides. What if I ask, please give me a shape with, let us do, please give me a shape with four sides. Can you think of a shape with four sides? Now, what if somebody did this? Does that look like it has four sides? That attribute is four sides? What can I do to make sure that if they're correct or not? Well, let's count the sides. 1, 2, 3, 4, 5. Ooh, this shape has 5 sides, but we only needed 4 sides. So go ahead and try drawing a shape with 4 sides. This one already has, or we found out that this one has 5 sides. That's not 4 sides. Go ahead and try it on your paper and pencil or with your sticks. Go ahead and make a shape with 4 sides. Now that we've talked about sides, let's quickly review what we learned about sides. Remember that they have to be straight. So here's my question to you. Which of these are shapes with more than 3 sides? Remember that we talked about this, more than 3 straight sides. So look at the chart and try identifying, which means finding, which of these shapes have more than 3 straight sides. Can you show me with your finger how many shapes you found? Or tell me how many shapes you found have more than 3 straight sides? Let me count with you. 1, 2, 3, 4, 5. No, this doesn't have any straight sides. 4, 5, 6. There are 6 shapes with more than 3 straight sides. If you got it, kiss your brain and shine your halo.
Let's quickly talk about corners and angles. So if the attribute has, maybe let's say, draw a shape with 3 angles. Remember that an angle is where 2 sides meet, okay? So if I have to draw a shape with 3 angles, I can go ahead and think. It has to have 3 corners and it's where sides meet. So maybe I can just 1, 2, 3, and use my sides to connect it. Now I see a shape with 3 angles. 1, 2, 3. What if I said draw a shape with 4 angles or 4 corners? Well, 1, 2, 3, 4. That looks like 4 corners or 4 angles. I have to let the sides meet. And that is my shape. Or it can look like this. Go ahead and try making a shape with 4 corners. Sometimes when you're being asked to make a shape with more corners, that's when it's easier to start using tools to help you move things around. For example, I'm being asked to make a shape with 5 corners. I'm going to use my tools to show you how we can use them to help build a shape with 5 corners, because sometimes it's kind of tricky to do it on paper pencil. It's not impossible, but you can definitely be able to practice first using it hands-on, and then you can draw it afterwards. Go ahead and watch how I created a shape with 5 corners. Sometimes it's easier to use straws or pencils or sticks that you find outside to help you build these shapes, because they're a lot more straighter. Remember that straighter was one of our words that we needed to know. Straight means that they're not going to flop around, they're just straight. So here's what I'm using. I'm using my little tents because I still have them. I know most of you guys might not have these, so that's why we can use toothpicks or sticks or anything that you see that's straight. So for example, the problem was to make a shape with 5 corners. Here I see a shape or an open shape with just 1 corner. So I'm going to keep trying to practice making a shape with 5 corners. Now if I try and I see, here is a shape with 5 corners. I can prove it if I count the corners. 1, 2, 3, 4, and 5. It's a little bit trickier to draw, which is why you can use the objects to help you make straight lines. But if you already know how to draw a shape with 5 corners, go ahead and just draw it with your paper and pencil as well. And if you just use your sticks, challenge your brain and try to draw it. I know it's tricky. Even I have a hard time sometimes. Let's keep going.
Now that we've explained angles and corners, it's the same as the last picture, but the question is a little bit different. Don't get confused. Let's see what the question says. Read it by yourself, and I'll read it with you in a little bit. The question says, which of these are shapes with 5 or more angles? 5 or more. Can it have 3 angles? No. Can it have 10 angles? Yes, because 10 is more than 5. So go ahead and check. Think in your brain which ones have 5 or more. So it can have 5 or more. And this time we're looking at angles. Don't forget, the angle is where two sides meet. Let's count. Does this one look like a shape with 5 or more angles? Nope. That means 1. I see 1, 2, 3, 4, 5 angles. Nope. Nope. This one has 5 angles. That's 2. This one has no angles. How many angles does this one have? 1, 2, 3, 4, 5, 6. Oh, definitely 5 or more angles. That's 3 so far. Definitely does not have 5 or more. Of course not. That's only 4 angles. 1, 2, 3, 4, 5. That has 5 angles. No and no. There should only be 4 shapes with 5 or more angles. Did you get it correct? Tell yourself, I'm good stuff. Okay, now that we reviewed a lot about the attributes and how they look like for shapes, we're going to give you a superstar challenge to go home. Now that we've talked a lot about attributes for sides, corners, angles related to shapes, here's my superstar challenge for you. This is something you can go ahead and go and do at home. So here's my task for you. You use toothpicks and marshmallows or sticks or straws to create shapes. Describe the shapes based on their attributes. So this is going to be a little fun activity where you can go ahead and use your hands to move shapes around. I thought it was pretty fun for toothpicks and marshmallows, but be careful not to poke yourself. But the marshmallows, you can eat them afterwards. How fun is that? But make sure before you start eating your marshmallows, you need to make sure you're making shapes that have sides, corners, and angles. You can create any shape as long as you're describing the sides, the corners, and angles. All right, guys, that was so much fun. We talked about shapes and attributes, how they look like. We practiced our fluency. Make sure you're still practicing a lot more math when you're home. And when you're bored, I mean, this is fun things to do. You can do shapes, corners, angles, sides, and then you can keep learning more. You are learners, leaders, and achievers. You can do anything if you work hard. Good job, and I'll see you next time.
Good morning, students. I'm Michael Roberts, Superintendent of the Osborne School District in Central Phoenix.
And I'm Quentin Boyce, Superintendent of the Roosevelt School District in South Phoenix.
We're pleased to have this partnership with the City of Phoenix to take Phoenix students on a new learning adventure right here on Phoenix TV.
Just because our school buildings are closed doesn't mean the learning stops.
We have the best, most creative teachers from Roosevelt and Osborne School Districts on board to provide you with a great learning experience.
Okay, students, that's the bell, so the Phoenix TV Study Hall resumes. Here's your next lesson.
Good morning and welcome to our classroom. I'm your teacher, Mrs. Hubetta. I'm a third grade teacher at Maxino Bush School in Roosevelt School District. I'm so happy you could be here with me this morning. So something about myself before we begin. One of the things that I have enjoyed the most while I've been at home on this pandemic has been being able to go outside and garden. It has been so much fun. I hope that you are enjoying yourselves at home with your families, staying healthy, being safe. So let's get started. Before we begin our lessons, I always like to begin with a celebration cheer. So our celebration cheer for today is going to be called the Oreo. When you get an Oreo, what do you like to do? Some people might like to just take the Oreo and take a big bite out of it, but that is not me. I enjoy taking that Oreo, breaking it apart, and then using each side to lick it. Yeah, I said it, lick it. So I'm going to lick one side and lick the other and then put them together. Now remember, this is a celebration cheer, so we're not actually licking our hands. We're just going to pretend that our hands are the Oreo, right? One more time. So take your Oreo, open it up. You're going to lick one side, lick the other, and then put it together. Pretty neat, right? So whenever you guys do something good today, I'm going to say celebrate yourself. You're going to take your Oreo. Great. I'm glad you got it. Let's get started. So today for our lesson, we are going to be using Envision Math. And we are going to be doing some word problems, right? Putting our math and our skills in real time, meaning that we should be able to use our multiplication and division skills for everyday problems. So here is one that we have, and it says, at the Fall Fest parade, members of the Cat Lovers and the Dog Lovers Club will march in equal rows. There will be 6 members in each row. How many rows of dog lovers will march in the parade? How many cat lovers will march in the parade? Complete the table, solve the problem any way you choose. Whenever I begin with any type of word problem, there is a skill that I use, and I like to read it, draw it, and write it. So I'm going to put that up here just to remind myself. That's R for read, D for draw, W for write. And remember, I always say, do not focus on my writing skills because they might not be that great. What is important is our math skills. So in order for me to read it, I'm going to start off with the word problem. And I'm going to look for the question it is asking me. The reason we always start with the question is because the question tells us what to look for, what we need to find the answer for. So I noticed that we have 2 questions. So let's look at the first one. It says, how? And the question is actually about the rows of dog lovers. And what they want to know about the dog lovers, they want to know how many are going to march in the parade. So what I'm going to use to help me solve this is I'm actually going to look down at that table and see what information they have in the table. So for the pet clubs, I see dog lovers and cat lovers. And for dog lovers, it tells me how many are at the parade. Now, let's go back one more time. It says how many will march in the parade. So if it's telling me the number of members at the parade, but then it gives me a blank for the number of rows. Let's go back. They're actually giving us some information. Let's see. I'm now going to look for anything that's going to help me solve. So it says, let's go back and read again. At the Fall Fest parade, members of the Cat Lovers Club and the Dog Lovers Club will march in equal rows. Nothing there, it's just telling me what they're doing. There will be 6 members in each row. Ah, that's what we need. I'm going to circle 6 members in each row. And I'm going to take back a look below at the dog lovers again. So it says dog lovers. Number of members at the parade is 24. That's important. So I'm going to write down 24. Let's see. Number of rows at parade. I don't know how many rows there are, but I know that there's 6 members in each row. Now remember, the question is not about how many total will be there. It's about how many rows of dog lovers will be there. So I'm going to take that 24 and I'm going to use it. And I'm also going to take that number 6 and I'm going to use it. 24 represents the number of members at the parade. The members could be the dogs, could be the owners. We don't know. We just know it's members. And then I'm going to take that number of members that are going to be in each row. I'm going to use both of those numbers to figure out the number of rows at the parade. Now, if there's 24 members and there's 6 members in each row, I know that my number of rows is going to be smaller. So I am not going to multiply. I'm actually going to use those two numbers to, you got it, divide. The opposite of multiplication is division. So my equation is going to be 24 divided by 6, because there's 6 members in each row, is going to tell us how many numbers of rows are at the parade. Now, if you remember our skip counting skills, I hope you do, we can use that. And this is a song that Miss Claren Harley uses with her students as well. She's the one who came up with it. So instead of me doing a drawing, which I could, we're going to use a skill that's going to help us get to our answer a little bit quicker. So 24 divided by 6, I can use the opposite of division or the inverse and multiply. And what I'm going to do is I'm going to take this 6 and I'm going to skip count by 6s until I get to 24, and then I'm going to stop, okay? If you remember, the 6s song is actually the happy birthday song. I'm going to keep track of my counting right here below, okay? So as I'm counting, I am going to be writing it down below. Ready? 6, 12, 18, 24, stop. I'd like to sing it all the way through, even though we've gotten to our answer, just to refresh your memory. So it goes 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. You got it. But our number we were looking for was 24, because that's what we were dividing the total members at the parade to figure out how many rows there are if there are 6 members in each row. I'm going to go back and count how many 6s we counted. So that was 1 row of members, 2 rows of members, 3 rows of members, and 4 rows of members. There are 4 rows of dog lovers at the parade. Great job, you guys. Celebrate yourselves. Now, we still need to figure out these cat lovers. So let's go back to our problem and find the question that's going to help us figure out what we need to know. So here's our second one. How? And the question is about total cat lovers. What they want to know about the total cat lovers. They want to know how many are going to march in the parade. Now, some of you guys are thinking, oh my gosh, she didn't do the draw it part at the top. Well, I really did, but this time I didn't do a drawing with an array or tape diagram. I used my skip counting as my drawing. Let's look at our chart that they give us, our table, where it says cat lovers. It does not tell us the total number of members in the parade. It only tells us the number of rows at the parade. Now, Let's go back. They want to know how many total cat lovers. So we're not actually going to do the same thing we did for the dog lovers. Let's go back and look for that important information again. I remember from the first problem we circled that there were 6 members in each row. If there are 5 rows at the parade and there are 6 members, people or cats, in each row, how many members are at the parade? We're going to use those 2 pieces of information to help us find the total number of members at the parade. And if you're thinking like I think you're thinking you are, I'm not actually going to divide this time because I want the total. I'm going to take those 2 factors, those 2 numbers to help me solve. So my first number they gave was 5. That's the number of rows at the parade. And I'm going to multiply that by the second piece of information they gave us, which was 6. There's 6 members in each row. That is going to give us our total number of cat lovers in the parade. And if you're thinking like I'm thinking, I think we can do skip counting again. Yes, all of those skills that we have, the skip counting songs, we're going to use again. So we're going to skip count by, now don't be tricked. We can skip count by 5s or we could skip count by 6s and it will still give us the same problem or same answer. But you need to know if you skip count by 5s, you need to skip count by 5 6 times. And if you skip count by 6s, you need to skip count by 6 5 times. So if I look back up here at the top, we already did the work, but I still want to do the song. Are you ready? 6's song. We're going to skip count by 6 5 times, and it should be one more than this one because this one we skip counted by 6 4 times. Count with me. 6, 12, 18, 24, 30. Wait, stop. That's it. Let's go back and double check and make sure we only counted 5 times. 1, 2, 3, 4, 5. That's it right there. 5 times 6 equals 30. So if 5 was the number of rows at the parade and 6 were the number of members in each row, then 30 equals our total. There is a total of 30 cat lovers at the parade. Time to celebrate. So let's get started with doing some math together. We are going to think about math in 2 different ways. The first step, or the skills we're going to use today, the first thing we're going to be doing is putting the problem in our own words. If we understand what it is that we're looking for, that's going to help us when we are solving our math problem. After we put the problem in our own words, the next thing we're going to do is find related facts. So see if we can take our same 2 factors and our product, that's the 2 numbers we're multiplying in our answer, and use them to also create a division equation. So let's look at the first example is one that is already done for us, and the second one we're going to work on together. The first one says Gina has 45 hats. That would be a lot of hats to draw. She is packing them by putting 9 hats in each of several boxes. She needs 5 boxes for the hats because 45 divided by 9 equals 5. And if you look at the equation, it said that she had 45 hats. That was our total. And then she was putting them into well, 9 hats in each box. That's the number that we divided by. That's where they got 45, and that's where they got 9. The answer, 5, tells us how many boxes she used. Now, the way that they created the multiplication equation was they took the number of boxes, they took how many hats were in each box, and that gave us the total of 45 she started with. Let's take a look at the next equation. Same type of problem with hats, but different numbers, and we're going to work on creating a division equation and a multiplication equation. We're cooking with gas. Chris has 42 hats. I'm going to underline 42. That number is important. It tells us the total. She puts 6 hats in each of several boxes. 6 hats in each box. So Chris has 42 hats. Remember, I want to put it in my own words. Chris has 42 hats, and she's putting 6 hats in each box. Sounds similar to the one that was already done for us. So if I'm going to divide or share, I know that 42 was our total. And I know that she's putting 6 in each box. I want to write it down. Make sure I'm keeping myself on track. Can you find how many boxes she needs using the same strategies as Gina? We're off to a great start. Now, I want to model this, and I want to we used a tape diagram before. This time we're going to use a bar diagram. So I'm going to draw a line up top, and this line is going to represent our total. Looks kind of like a little bar, and I'm going to label it 42 because 42 is our total. Now, the area down below is going to match up with this, except this is going to be what we're dividing it into. We're dividing it by 6, and 6 is the number of hats in each box. Now, when I skip count by 6s and I fill this bar up, I'm going to stop at 42. That's going to tell us how many boxes she needs. And if you're thinking like I'm thinking, 6s, we know a song. We can skip count, and then we're going to stop when we get to 42. So I'm going to draw my 6s, and then I'll put my boxes later on because the boxes aren't really important. 6, 12, 18, 24, 30, 36, 42. Stop. Let me go back and double check. 6, 12, 18, 24, 30, 36, 42. Perfect. Now, I figured out how many 6s I needed, but remember, these aren't just 6s. These are actually the number of hats, and each of these blocks or bars that we're doing represent a box. So inside each box, there's 6 hats, and I want to figure out how many boxes she needs. So what we're going to do is go back and count. How many boxes of 6 do we have? That's 1 box, 2 boxes, 3 boxes, 4 boxes, 5 boxes, 6 boxes, 7 boxes. Chris needs 7 boxes. So she had 42 hats. She put 6 hats in each box, and she has 7 boxes total. Now, I want to take and I want to use those same numbers to create a multiplication equation. So, if she has 7 boxes times the number she put in each box, 6, That's going to give us 42 as our total. Great work, students. Give yourself a celebration cheer. So here's what we did today. We solved real-world problems. We repeated the problem in our own words to make sure that we understood. When we were solving, we went back and we looked for important information in the problem that was going to help us solve. We used a bar diagram to model or to show our work and our thinking. And then lastly, we want to remember that multiplication and division, they're different because they're opposites. And before we go, I have something for you to work on at home. Homework, of course. Who could leave school without homework? There are 5 pancakes in a stack. Elise makes 40 pancakes total. How many stacks does Elise make? Remember to go back, put the problem in your own words. Look for important information that's going to help you solve. And finally, use the tape diagram to help show and model your thinking. Remember to relate multiplication and division to one another. So you should be able to write a multiplication problem and, using the same numbers, create a division problem. It was so good to have you guys with me today. I appreciated you so much, and I hope that you guys are doing well. But before we go, let's celebrate ourselves again. Great job for all your hard work today. See you soon.
Good morning, boys and girls. My name is Miss Call, and I am a 5th grade teacher over at Clarendon Elementary School in the Osborne School District. Fun facts about me. I've been teaching for 12 years, and I have only taught in the Osborne School District. I have taught 4th grade, 5th grade, and 6th grade. Today, we are going to be doing a math lesson. And so today, after my introduction, we're going to go through a modeling of the lesson. And then at the end, we're going to practice some problems together. So if you do have a piece of paper and a pencil, go ahead and grab that and come back so that we will have it at the end of today's lesson when we practice together. All right, let's get started on today's lesson. Today, we will be dividing fractions with models. So let's go over that agenda today. Today, we're going to start out with a think about it, followed up with our learning goal. Then we're going to review some vocabulary and skills. Then I'm going to model a couple problems of dividing fractions with models on the slides. And then we'll come back together to do some practice time with that paper and pencil that you grabbed. All right, freezer pops. Raise your hand if you have heard of the term freezer pop. Have you ever eaten one of them? Let's see what these look like. Here they are. All right. Have you ever had a freezer pop? If I have 5 freezer pops and split them each in half, how many pieces do I have now? How would you write this as an equation, and how could you solve these types of problems using drawings and models? These are the types of questions that we'll be able to answer by the time we are done with our lesson today. So let's think about this. Today's learning goals. Students will be able to explore division of fractions by drawing models, and students will be able to divide fractions by drawing models. So let's do some basic vocabulary review. On your piece of paper, I want you to take a minute and think about when you hear the word division, what does that mean to you? What comes to your mind? Go ahead and take a few seconds to jot down any ideas when you hear the word division. Ready? Go. All right, let's go over some of those words or that you think wrote down for division. Fractions, dividend, divisor, quotient, each, per, distribute evenly, half, equal groups. These are all terms that we use when we hear the word division. So let's review, what does division mean? Here I have two whole numbers, 12 divided by 3. What the problem is asking me is how many groups of 3 are there in 12? So if you notice, I have my smiley faces down here. I have 12 of them. I'm going to go ahead and I'm going to circle groups of 3. 1, 2, 3, 4. 12 divided by 3 is 4. So there are 4 groups of 3 in 12. Let's try this one. 10 divided by 5. This is asking me how many groups of 5 are there in 10? So I'm going to circle groups of 5, and how many do I have? 1, 2. 10 divided by 5 is 2. So now let's practice what it means when we're dividing fractions with models, not whole numbers, but fractions. So what do you think this means in words? 6 divided by 1/2. How would I complete this sentence frame here on my slide? Great, it's asking us how many groups of 1/2 are in 6. So let's go ahead and see how would we solve that with pictures. We're going to go ahead and start with our 6 holes. So I drew 6 whole boxes. 1, 2, 3, 4, 5, 6. And now I want to know how many halves are in that 6. So I'm going to divide each of my holes into 1/2. So I'm partitioning each box into 2s because that is my denominator of a half. Now I'm going to go ahead and circle how many halves there are in that 6. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My answer is 12. 6 divided by 1/2. I have 12 halves in 6. How would we write this? 4 divided by 2/3. How am I going to fill in that sentence frame? That's right. How many groups of 2/3 are in 4? So let's go ahead and let's draw that. I'm going to start by drawing my 4 holes. 1, 2, 3, 4. And then I'm going to break each hole into thirds because that's my denominator. So now I have 1, 2, 3. Each one of my holes are broken up into thirds. Now I want to circle 2/3 of my holes. So I'm going to go ahead and start. I have 1 2/3 there. I have another 2/3, 3 2/3, and another 2/3. Notice that I still have some parts uncircled. I'm going to go ahead and circle 2 of those because there's still 2/3. So there's 2 out of 3 and another 2/3. So 4 divided by 2/3 is 1, 2, 3, 4, 5, 6. My answer is 6. Let's try another one. 3/4 divided by 1/2. How would I say that? How many groups of 1/2 are in 3/4? Let's solve it with pictures. I'm going to start out by creating my hole, and I'm going to go ahead and draw my 3/4. So using vertical lines, I'm going to divide it into fourths. And since it is 3/4, I'm going to go ahead and shade in 3 out of those 4. Now I need to divide it going horizontal with my half. So now I'm going to divide my box going horizontal in a half. So that's 2 parts. So I have 1/2 here and 1/2 here. I'm going to go ahead and circle 1/2. I want to know how many halves I have. So notice that I have 3 boxes still here unshaded. I'm going to go ahead and cross off one of my boxes, and I'm going to move it into this empty area right here for my half. I now have one whole half, and then I have 2 remaining out of 1, 2, 3, 4. So I have 1 and 2/4. So how many halves are in 3/4? 1 and 2/4. All right, let's get ready to do some practice. Go ahead and get out that piece of paper and that pencil, and we're going to do some problems together. Okay, so now we're going to practice doing some problems together. So let's go ahead and get started. Get out that pencil and piece of paper and we'll get started. The first problem we're going to do together is going to be 1/2 divided by 1/4. Okay. Now remember, we're wanting to ask ourselves how many groups of 1/4 are in 1/2. Okay. So how are we going to show that using a model? So the first thing I'm going to do is I'm going to go ahead and draw my 1/2. I'm going to shade in 1 because that's my numerator. Okay. And then I'm going to go ahead and I'm going to now divide, going horizontal, my 4ths. Okay. And I'm going to go ahead and circle 1/4. Okay. So now I know that my denominator is going to be 1, 2. Okay. And then how many total shaded do I have? 1, 2, 3, 4. So now I have 4 divided by 2, because we know that a fraction is the same as division, which is going to give me 2. So my answer is 2. If you wanted to, you could have also taken away a shaded part here and shaded in up here. Okay? So then that would be 1 whole. But then you still have your 2 left over out of 2. So that would be 2 out of 2. And we know that 2 out of 2 is the same as 1 whole. And 1 plus 1 gives me 2. So there, how many groups of 1/4 are there in a half? There are 2 1/4 and a half. All right, let's try our second problem. 3/4 divided by 4/5. Who can tell me the sentence frame we're gonna write for this? What are we wanting to say? Good. How many groups of 4/5 are in 3/4? So the first thing we're going to do is we're going to draw that first fraction 3/4. Okay, so I'm going to go ahead and divide it with vertical lines into fourths. 1, 2, 3, 4, and I'm going to shade in 3. Okay. Now I'm going to go ahead and grab a different color. You might, if you don't have another color, that's okay. I'm going to now do my horizontal lines into 4/5. So 1/5, 2/5, 3/5, 4/5, 5/5. And I'm going to go ahead and circle 4 out of those 5. So 1, 2, 3, 4. Okay. Notice that I have 3 extra shaded boxes at the bottom. I'm going to go ahead and I can move those into my 4/5 that I already squared, because I want to know how many are going to fit into my box here. So I would do 1, 2, 3, and then I can X those off. Now I'm going to count up my inside of my box. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's going to be my numerator. And my denominator is going to be the total amount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my answer is 15 16ths. Now, if you didn't want to move the shaded boxes into here, you can just count the total shaded amount. You would still get 15, and then you're just going to count how many are in the box here. 16 would be your denominator. 15 16ths. All right, let's try one more. One more. Let's see if I can get this paper out here. All right, one more problem. Let's try 3/5 divided by 2/3. Okay, what is the question that we're looking to answer? I'm going to put it right over here. How many, that's right, groups of 2/3 are in 3/5? Okay. Which fraction am I going to draw first? Am I going to draw 3/5 or 2/3? That's right, 3/5. So let's go ahead and get started by drawing 3/5. I'm going to go ahead and break it up into fifths. And I'm going to shade in 3. Okay. Now I'm going to go ahead and I'm going to create my second fraction, 2/3, going horizontal. And I'm going to go ahead and box 2 of those 3. Now my denominator is going to be how many total are in my box area. So let's move to the denominator first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And your numerator is going to be how many total are shaded in my picture here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my answer is 9/10. Now, if I wanted to go ahead and show this, I can go ahead and cross this off and shade it in here. Which gives me the same answer of 9/10. So how many 2/3 are there in 3/5? 9/10. All right, so that's going to end today's lesson on dividing fractions with models. Remember to that you're going to draw that first fraction first with your vertical lines, shade them in. Go ahead and create your second fraction with your horizontal lines, box that fraction, and then we want to figure out how many that second one is how many groups we're making. Okay. All right. You could always practice this by creating come up with 2 fractions and practice on your own. So that piece of paper, any fractions, you can try and see if you can do it. It was wonderful having teaching with you today. Hope you all have a fabulous day, and we will see you next week. Bye.
Hi, everybody. My name is Mr. Stacy. I'm a 7th and 8th grade math teacher at Osborne Middle School in the Osborne Elementary School District, and I'm here today because we're going to be doing some math. Now, if you've been following this entire series while we've been at home on this very channel, you may recognize me from my former videos where we did math with Hershey's Kisses, or the sequel where we did math with red Hershey's Kisses. I know. Thrilling, right? Well, we're going to be doing some more math. We're going to be solving some more equations, but this time we're going to be solving some different types of equations. Not just your standard run-of-the-mill equations that involve the distributive property. your heart just started like pounding. You're like, oh my gosh, the distributive property. I've been waiting to do the distributive property. 3 months I've longed to do the distributive property. Well, I've been sitting here at home just thinking about the distributive property. First of all, what? Secondly, hey, here's your chance. We're going to be doing just that. So let's go ahead and get started. Now, as I'm pulling this up, I do want to let you know if I am talking way too fast for you, and you're like, Mr. Stacy, please, 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 please slow down. Unfortunately, I only have 20 minutes, and we're going to be covering a lot of ground here. So if you want to go back and rewatch these videos, you can go to the City of Phoenix's YouTube channel, where you can watch all of these videos again. All right, so our topic for today is writing and solving equations that involve the distributive property, like I already said. And if that doesn't sell you, if you're not super excited just based on that premise alone, well, let me tell you, you are also going to be getting this, what we call the first installment of a series based on bad math art by Mr. Stacy. Now, you might think, well, Mr. Stacy, you seem like the type of person who'd be quite good at art. No, I am profoundly bad at art, and therefore, you're going to get a real treat today. We're only going to be drawing one real set of pictures, but it's going to help us to visualize something that we're doing. All right, so what's our big goal? What are we trying to achieve here? Well, this is what we call a standard or a state standard, and Arizona tells us, teachers, what are the things that we need to teach our students every single year. And one of these 7th grade standards, and it also is part of an 8th grade standard, is to solve word problems leading to equations of the form px plus q equals r, and p times the quantity x plus q equals r, where p, q, and r are specific rational numbers. You might be like, oh my gosh, what does that even mean? It's actually quite simple. Px plus q equals r is just an equation where, you have something times x plus something equals something else. That's an equation, 2x plus 4 equals 8, or px plus q equals r. That's all it is. So solving a word problem that leads to an equation that looks like this, but we're going to focus today on word problems that lead to equations like this, p times the quantity x plus q equals r. So what does that mean? Well, that's if you have something like 2 times the quantity x plus 4 equals 8. We have p is this number here, then these parentheses are the quantity x plus q equals r, okay? Those are just forms of equations. And we are going to be working with these because we want to write ones that involve the distributive property. Now, all this is saying where p, q, and r are specific rational numbers, it's just saying that they're not like random things in this equation. No, they're actual numbers. Okay, that's all that is. So all we want to do today, to boil it down, is take a word problem that is going to have us write an equation that involves the distributive property, write the equation, and then solve it. That's it, okay? Now, before we do any of that, I do want to give some vocabulary. I'm going to be using a lot of words throughout this, and you'll hear me briefly drop the word variable. That just means a letter that represents some unknown amount. So I don't know what the value of x is in this case, but I can find it, and it does stand for a specific number. Okay, now you might also hear me talk about a number that's by itself. Now in this case, 4 is always going to be 4, regardless of where it is. If I move it over here, it's still going to be 4. If I put it over here, if I flip it upside down, it's still going to be 4. It is constantly the same thing, and that is called a constant. Likewise, 19, since it's just a number by itself, kind of hanging out here, is also called a constant. It is constantly the same value. Now, the one that you may not have heard, well, hopefully you've heard it, but it's the toughest one to remember, for me at least, is this one right here. The number 3 multiplied by x. Anytime you have a value being multiplied by a variable, that is called a coefficient. All right, coefficient. You can say that one a couple times if you need to practice it. Coefficient. Coefficient. Feel the way that that feels as you say it. Coefficient. It sounds kind of like going fishing. coefficient, 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 all right? It's a tough word, but it starts with the same two letters as constant, which makes it even more confusing. I don't know why they chose that, but coefficient is a number being multiplied by a variable, meaning that we have 3 of whatever it's being multiplied by. So in this case, 3 x's. We have 3x, all right? Now you may also see it in a situation where it is not just being multiplied by a variable. Okay, again, this is a variable. We know that already. Think, what is this number by itself? We just said it. Constantly the same value regardless of where you move it. Oh, duh, I gave you like a massive hint. That one is called a constant. Okay, this one, now this one is deceptive because people might think, well, it's just a 9 by itself. Well, I mean, I guess, yeah, but really if we use our law of subtraction, our rule of subtraction, then we see that it's not just 9, it's actually -9 because subtracting 9 is the same as adding -9. So this is the constant -9. Which leaves us with, oh, hey, check this out. Here's another one of those numbers being multiplied by a variable. In this case, that means that 2 is the coefficient to x. We have 2x. Well, that leaves a few other random things that we need to deal with then. What is this 5? Well, if you remember, I said that this 2 is just showing how many of that thing we have. Okay, we're multiplying 2 times that thing. It works the same way. We're saying we have 5 of that thing. Okay? And so that means that 5, even though it's not being multiplied directly by a variable, it's being multiplied by this set of numbers inside the parentheses. And so 5 is also a coefficient. All right? So then we just have to give a name to what is this series of numbers inside the parentheses. If 5 is the coefficient to it, then what do we call all this stuff inside the parentheses? Well, this is the quantity. Okay, so I would read this 5 times the quantity 2x minus 9, meaning I have 5 sets of the quantity 2x minus 9. All right, and that's our big idea. If you understand that piece right there, you're going to be absolutely fine writing and solving these equations because you just need to remember that this coefficient 5 means I have 5 of that, and whatever that is has to be exactly the same. So in this case, I'm saying I have 5 of the exact same thing, and the exact same thing is 2x minus 9. So I have 5. 2x minus 9, I have another 2x minus 9, I have another 2x minus 9, another 2x minus 9, and yet another 2x minus 9. I have 5 of the exact same thing. That exact same thing again is 2x minus 9. So you might then go, okay, well, if you've got 5 sets of 2x, that's going to give you 10x. And then if you have 5 sets of -9, that's going to give you -45. So really, this is the same thing as 10x minus 45. And you'd be exactly correct. Because again, we have 5 of the exact same thing. That's what a coefficient to a quantity means. So I have 5 2x's, and I have 5 -9's, which means I have a total of 10 x's and -45. There we go. Again, coefficient, coefficient, variable, constant, and then this whole thing is called a quantity. All right, now that I've scribbled all over that page, let's put it into practice. Let's write about it a little bit. 4 boring friends went to a movie theater and bought the exact same snacks at the concession stand. They each bought 2 boxes of raisins and a bottle of water. Now, I want to emphasize that they're not boring because they bought raisins and water. Now, you might not think that's the best snack, but they're healthy at least, so they're boring because they all got the exact same thing. Well, we need them to be the exact same thing in this case because that's how the distributive property works, okay? So I need to visualize this first. I'm the type of person where if I don't have a picture, I don't know what's going on. They each bought some snacks, blah, blah, blah. There's raisins, there's water involved. Okay, So I'm going to draw this out. Here's 4 boring friends. Oof, here we go. Draw. Okay, yeah, that wasn't too bad. Oh, he looks cross-eyed, but happy at least. Okay, here's another, wow, giant head man. Okay, his eyes are, that one's a star or something, and he's neutral expression. And now you're starting to see, wow, Mr. Stacy, you are really bad. These, oh my gosh, their heads just keep getting bigger and their bodies keep getting smaller. Okay, and this guy, oh, he's got huge eyes, but at least, again, he's very happy. And then here we'll just, oh, very, he's wearing like a dress or something, or she, whoever this is. Okay, we've got 4 boring friends. They each bought, okay, this is where the drawing is going to be important because they bought the exact same snacks, which is leading me to believe that we have a distributive property situation coming up. Okay, they each, that's so important, they each bought 2 boxes. Not all of them together bought 2 boxes, they each bought 2 boxes. I'm going to give each of them 2 boxes of raisins. Oh my gosh, that doesn't look anything like a box. Okay, they each have, wow, they each have 2 boxes of raisins. They're so happy to have them. They each bought 2 boxes of raisins and they each bought a bottle of water. Okay, so he's got, oh, that's a candle that he bought. No, that's a bottle of water. Oh, that's a very chunky bottle of water with a disconnected cap. Check those before you try to get something really good. Okay, that one looks a little bit more like a bottle of water. And he got, wow, this giant bottle of water. And goodness gracious, I can't draw. Sorry, guys. But again, bad art with Mr. Stacy. Cool. So they each have 2 boxes of raisins and a bottle of water. You might be like, well, how much do those cost? We have no clue how much they cost. It's probably expensive because it's a movie theater. But if we want to represent how much these cost, then we would have to represent them with a variable. So we might say R is the cost of, well, it makes sense that that would be a box of raisins. So R is going to be the cost of a box of raisins. And we'll make W be the cost of a bottle of water. Okay, so we've got R is the cost of a box of raisins. We've got W is the cost of a bottle of water. So if I wanted to write an expression to model this, I would say, okay, well, there's 4 of them. They all bought the exact same thing. And I'm going to write this up here. There's 4 of them. And if they all bought the exact same thing, that means it's 4 times. I just need to put in a coefficient. Okay, so in this case, 4 of them got the exact same thing. So again, 4 times whatever this is. We just need to figure out what that is. All right, 4 people bought the same thing. So they each bought 2 boxes of raisins. So, well, how could I represent that? Well, if R is the cost of a box of raisins, I'd say, well, they each bought 2, and R is the cost of a box of raisins. So they bought 2 boxes of raisins, and then they each bought 1 bottle of water. Now, I could write 1 W, but really, they each just got a water, so I'm just going to write W. Okay. Look it, I just wrote this expression with a quantity that will require the distributive property, and all I had to think was, okay, there's 4 of them. They got the exact same thing. That tipped me off to the fact that I was going to need parentheses, all right, a quantity. So 4 times what? What did they all buy? Inside the quantity's got to be what each of them bought. 2 boxes of raisins and a bottle of water. Now, if I use the distributive property here, I would see, well, 4 times 2 raisins would be 8 boxes of raisins. Does that make sense? Well, yeah, look at them. They each have 2 boxes of raisins. That's 2, 4, 6, 8 boxes of raisins. And then 4 times W, 4 bottles of water. I did it right. This is exactly it. So now that we've done that, let's take a look at the next piece of the puzzle. Let's complicate it a little bit. So they went to the boring friends went to a movie theater and they bought the exact same snacks at the concession stand. They each bought 2 boxes of raisins still and a bottle of water. Again, to write this expression, I would say, all right, I have 4 friends. They all bought the same thing, again, making them boring. But if they all bought the same thing, I can make that a quantity, meaning there were 4 of them, and they all bought that. All right, again, if R is the cost of a box of raisins and, oh, wait a minute, we now know bottles of water cost $8. Do we know how much a box of raisins cost? No, we don't. So we can still write, they each bought 2 boxes of raisins, but in this case, we don't need to represent this with a variable. We already know how much the bottle of water costs, and that is $8. So they each bought 2 boxes of raisins and then paid $8 for a bottle of water. How many of them did that? 4, and they all did the exact same thing. So 4 times the quantity, 2 boxes of raisins and an $8 bottle of water. There is our more advanced expression. Now, if I really want to get into equation mode, here is the full question that you would likely get. And you might be thinking, wow, they paid $8 for a bottle of water? Have you been to a movie before? You know that I'm right. Those bottles of water are insanely expensive, but there is a reason for it. Okay, so we've got our 4 boring friends. They went to a movie theater. They bought the exact same thing. They're 4 friends, and they all bought the exact same thing instantly. If they bought the exact same thing, I'm going to think, oh, that's a quantity. 4 times what? Again, 2 boxes of raisins and a bottle of water. We still don't know how much a box of raisins costs, and as a matter of fact, if you look, the question is asking, how much does a box of raisins cost? So they bought 2 boxes of raisins and a bottle of water. They still give us this information that a bottle of water costs $8. So I've got the same expression as before. 4 people each bought 2 boxes of raisins and a bottle of water. Oh, but here they spent a grand total of $152, which means all of this right there equals $152. And you know what? Just by using some basic deduction, I realized that this problem was a distributive property problem because 4 people bought the exact same thing, and that exact same thing is written right here. 2R, 2 boxes of raisins, and an $8 bottle of water. At which point I can think, well, if they each bought 2 boxes of raisins, that means they have 8 boxes of raisins. If they each bought an $8 bottle of water, that's $32. And that gives us a total of $152. But you know what? If we want to solve this equation, we can think, well, if they spent $32 on bottles of water, we can just get rid of that from the grand total, leaving us with 8R, or the 8 boxes of raisins, being $120. Let's pull this over here. So we've got 8R is $120. If 8 boxes of raisins are $120, well then let's divide it by 8 and figure out 1 box of raisins, 120 divided by 8 is $15. All right, so all we needed to do is we needed to say 4 people, set up our quantity because they all bought the same thing, and then write in what's in the quantity. 2 boxes of raisins and an $8 bottle of water equals our grand total, and we can solve that equation to find out that a box of raisins cost $15. So let's go back very quickly and check to see, did we meet our goal? Our goal was to be able to solve word problems leading to equations of the form P times the quantity X plus Q equals R. And we wrote the equation 4 times the quantity 2R plus 8 equals 32. Look at P times the quantity X plus Q equals R. We did it. Congratulations. Now, just to give you a little tidbit of information before we go, the reason all that food is so expensive at the movie theater is because when you pay for a movie ticket, the money that you pay for the ticket doesn't go to the theater. It goes to the studio that made the movie so that they can make more movies. The only way for a movie theater to make money, except for a little bit of that ticket sale, is to charge a lot of money for their food. So that's how they get the money. That's why you're always paying so much. It's not because they're just super greedy, which maybe they are or whatever, but that's why all the food costs so much. That's free. Free little trivia for you. We did it, guys. Congratulations. Thanks for sticking with me through this whole thing. And come back next week when we are going to be pushing this even farther. We're going to learn even more about how to solve, do all of this stuff with the distributive property in an equation. Thanks again for watching, everybody. Stay safe.
You've been watching Phoenix TV's Study Hall, brought to you by District 8 and our partners at Osborne and Roosevelt School Districts. Tune in Monday through Friday from 9 a.m. to 11 a.m. for more Study Hall. I hope you learned something today and keep up the great work.